So hey, hello everyone. This is Sanjay here. So today's topic is basically about the formula. One big formula. One just a bit disclaimer here. This derivation and all they won't ask for competitive exams kind of thing, but still some teachers teach it because when you see the the derivations and all, you will get the feel one thing. Okay, if at all you say I don't want the feel and all, I just will by heart the formula. One more benefit is that knowing the derivation and all, like in the exam, if you forget the formula, for example, this the limit of sum, if you take, it is a big formula, right? Big formula. We will just derive and see. Even I don't remember the formula exactly. I just derive and I will show you. So if you forget some formula for direct applications, it will be some easy direct application of formula, but you will forget that in the exam, in just panic or something. So for that you can you can just derive it, and if you know the concept, basic concept, if it is clear, then you can derive anything. Okay, so here first of all I'll explain what is limit of sum. Okay, so basically integration. Okay, first of all I'll say this is reference with reference to the integration chapter in NCERT. So mostly in your board exams they'll ask this for 6 marks and all, like maybe 6 or 5 marks. Not the derivation, like they'll give one simple function, and they'll ask you to integrate and find the value, but not directly. For example, if f of x is equal to x square, they give, you cannot directly reduce formula of or integration of x power n dx is equal to x power n plus 1 by n plus 1, so it will be x cube by 3. You cannot like plus here. Okay, you cannot write like that, because they will mention there with using limit of sum, like that they will mention. So what is limit of sum? Okay, before integration, you should have studied the chapter of differentiation, right? Differentiation and application of derivatives, chapter 5 and 6 respectively. So what happens in the differentiation part? In the differentiation, what you do, you just simple meaning of differentiation is breaking down into fragments. Okay, many people, like I come over many people, okay, come across many people, they don't know what is the meaning of differentiation only after finishing 11th standard. Okay, maybe this you will learn in only 12th standard, but in physics and all you will get to encounter some concepts of this differential integration in physics 11th. But still after finishing the 11th, people don't know, like it's not their mistake actually. So I just thought we can just explain some basic concepts in differential integration, but this is not 11th concept, but you can just learn it. Okay, no mistake and all. So what is differentiation? Differentiation is basically breaking down into fragments. That is English meaning of differentiation. And integration means integrating again, joining it again. Okay, for example, differentiation mathematically, if you see, it is for example, one function, if you differentiate, you will get the a slope of the function, correct? That is differentiation. And integration, what integration will give you? It will give the area under the curve. Okay, so differentiation means it will give the slope of the tangent at a particular point. Generally, if you want, you can generally consider it as a curve. Okay, when a curve is given, when you differentiate it, it will give the slope of the tangent, and when you integrate the curve, it will give the area under the curve. Okay, but that also depends. Okay, for example, if x square, if you take, with respect to dx, if you do, you will get the area with respect to x-axis. Okay, and with respect to y-axis, you will get the area of the y-axis. Okay, and obviously we will mention some limits. Okay, that is basically the definite integration. Only if we integrate, we will get some function, that is indefinite integration. And definite integration basically will find the area. For example, if x square, if you take, and you just mention like 0 to 1 if you take. Okay, so 0 to 1 if you consider, 0 to 1 if you consider, you can get the area. For example, I'm saying like this. Okay, for example, this is a curve, and some in first quadrant the x square will be like this, correct? So this will be 0 if you can consider, and this will be 1. Okay, so yeah, so if x square is 0 to 1, if you consider, you can get this area, correct? So this is 0, 0, that is 1, 1. Okay, this is 0, 0. Okay, so if you consider this curve, integration of x square dx. Okay, dx means with respect to x-axis. Okay, I mean not with respect to, like with the area that is making with the x-axis, you can find. If you take 0 to 1, you can just directly integrate x cube by 3 and 0 to 1 again. So answer will be 1 by 3 square units, correct? So basically this is what integration means. Okay, when you just integrate x square, you will get x cube by 3 plus c you will leave. Okay, this is indefinite integration. When you do definite integration, you will get definite like you will get the value of the area. Okay, this is basic meaning of integration. But even when you studied in 11th class or whenever, okay, you would have studied this formula, right? Integration of x power n dx is equal to x power n plus 1 divided by n plus 1 dx, plus c, correct? Have you ever wondered how this formula is derived? So in one way you can say when we differentiate this function, you will get x power n. Okay, because if you want, you can differentiate this. Okay, 1 by n plus 1 is constant, so you can take this out. And if you differentiate this, x power n, when you differentiate, what will come? N into x power n minus 1, so it will be n plus 1 into x power n plus 1 minus 1. This will be cancelled, so 1 plus 1 plus 1 will cancel, so x power n will come. This is okay, but is there any derivation directly when you integrate this? How you can get, you are getting this one? Yes, it is there. Okay, that is basically the limit of sum. Okay, so basically when you integrate, you will get the area, and that area is directly found. One method is there. Okay, that is known as limit of sum, using which you can find the area. So basically, if you consider this curve, okay, for example, one random curve I'm drawing, okay, not x square anything, okay, this is some random curve. Okay, you consider this x coordinate as a, okay, and of this point you can consider it as b. Okay, now you want to find this, for example, consider this as f of x. Okay, now you have to find the area of this curve with x-axis from a to b. Basically you have to find a to b f of x dx. This only you have to find, correct? Okay, so how can you find? There is no formula for the function itself, you don't know. General formula we can derive. Okay, now for finding area, we are taking the help of limits. Okay, how limits is useful here? Limits in 11th you should have studied it in 11th chapter, and 12th also in that limit continuity and differentiability, in the continuity differentiability chapter, limits you will get. Okay, so what we do generally, we just take a rectangle here. Okay, some rectangle I'm taking here. Okay, now what I'm saying, if you construct some rectangles like this, okay, for example like this, pardon my drawing actually. So if you keep on constructing such rectangles area, this is L cross B. So if you find this width and this length you can find, then you can multiply and find the area of this rectangle around. Like that you can find all the rectangles. That is no problem. Okay, but the problem arises here. Okay, you cannot fit exactly a rectangle inside this curve, correct? Because see here this part is not covered. Can you get it? Here this part is not covered. Here this small part is not covered. Here this small part is not covered. Here this, like this. Okay, like this you are not getting the area of this. So who will find separately this area and add everything? That is useless. Only useless fellow will do it. Okay, so what happens here? For this only you have to consider the concept of limit. Okay, what you are doing, one rectangle you consider. Okay, for example, this rectangle you consider. This rectangle, this width, right? This width, okay, this width, oh my god, okay, this width, you are you're just shortening the width. Okay, here this width, okay, to as much small as possible. Okay, so now can you just predict some limit coming over here? So we just take this small distance as h. Okay, so when you almost you have to like shorten this, that almost this line and this line will coincide. Okay, almost, okay, not exactly. That difference is negligible actually. That is actually h. Okay, that distance you will almost coincide. So what will happen? This line, if it comes here, okay, for example here, this error is negligible. Can you see? Like this, we draw another rectangle here. This inside this rectangle we draw another rectangle, so that this part we were not getting it at the beginning, right? The rectangle was did not cover this part. That part now that error reduces to minimum amount, correct? So what we do is we just reduce the size of the rectangle so that this part is covered. Okay, you can just try it out, some strips and all. Okay, you can just try it. So this this rectangle, you just imagine the line, bringing this line on coinciding it over here. Okay, if you coincide like just over here, and similarly you draw many rectangles here. So now you can understand that this part is covered. Imagine, okay, like this. So for example, I'll explain it here. So when you bring this line closer over here, you can draw, you will draw this line, okay, and one more rectangle inside this rectangle only you can draw like this, like this. Now this error is reduced here. So such that similarly you consider n rectangles, okay. Because this A to B is defined, but A to B, it can be from any 1 to 100 or 1 to 1000 or anything it can be. So we just take it as n, okay. We don't know that, okay. So and n, we don't know the n value, so we just tend it n to infinity, okay. N can be n number of rectangles, okay. So what we do, limit n tends to infinity, okay. Now this limit you just remember here, okay. I'll come to this again. So what will happen here, now this first point here, this is what, a comma f of a, correct. I am considering this first rectangle as this distance as h, okay. I for example only I told this is h. Now consider this as h, okay. Every this is the main point, okay. You have to make it like shorten the width that much, such that every rectangle has the same width, okay. That is h only, which is negligible obviously, but you have to make it as actually you're not going to do this anywhere, okay, but just know it how to do, okay. So this h is reduced so small, and the number of rectangles, n number of rectangles are there, right. All the rectangles with this h only, correct. So now the a next point you consider, that will be how much, a plus h. Can you get it? This is a and h distance. So for example consider this point, okay. This point will be how much, a plus h comma f of a plus h, correct. Similarly the next point will be a plus 2h comma f of a plus 2h, correct. Similarly it will be going up to a plus nh comma f of a plus, oh sorry, once again, this is wrong, okay. The last point will be a plus n minus 1 into h plus f of a plus n minus 1 into h, sorry, not plus comma. So why is n minus 1? So when you consider this separate rectangles here, okay, so these small areas are missing, that's why we just shorten this width and tend this n rectangles to infinity, okay. So first of all we just find what are the coordinates here, okay. For this point, first point if you take, it will be a comma f of a, correct. And next point if you take this one, it will be a plus h comma f of a plus h, okay. And next point if you take, it will be a plus 2h comma f of a plus 2h, and so on up to, if you take the last point will be not nh, okay. This will be f of a plus n minus 1h comma f of a plus n minus 1 h. Why not nh? Because see, when you consider this rectangle first of all, okay, first this rectangle considering, okay, you are knowing this one, only this coordinate, okay, not this one, okay. So for convenience you are taking only the left side of the rectangle, okay, this point, okay. So this left side of the rectangle, if you take every rectangle you're taking like that only, okay. A plus f of a comma f of a, this will be when you know this one, this y coordinate will be f of a, right. Y f of a means this length will be f of a, this will be h, this small, so area will be h into f of a, correct. Similarly this next rectangle if you consider, this will be a plus h comma f of a plus h, so the y coordinate will be f of a plus h. Again the x coordinate will be h only, so it will be h into f of a plus h, correct. So similarly you tend up to a plus n minus 1 into h, so h into f of a plus h into f of a plus h, and so on up to h into f of a plus n minus 1 into h, correct. So we can take h common outside, so this will be f of a, f of a plus h, and so on up to f of a plus n minus 1 into h. Now but limit is to we have n tends to infinity here, but in this term we don't have any in this terms and all, only in this term we have n. So what we will do here, but in all terms we have h, correct, h everywhere. Okay, so here if you notice carefully, from a to b, okay, from a to b, what is this length, total length? It will be b minus a, correct? For example, if you consider, for example, this is 1, this is 3, what is it, what is this length? 3 minus 1, this is 2 units, correct? Similarly, this length will be b minus a. So one important result to remember is b minus a, and one rectangle length is h, correct? One, I mean the width h. Similarly, how many rectangles are there? N rectangles are there. So h plus h plus h up to n rectangles. How much? It will be nh, right? So this will be nh. Remember this result forever, at least till your 12th exam is over. Okay. So n will be b minus a divided by h. Okay. So we can just replace h here by, here is h is there, right? B minus a divided by n you can replace, or you can do one more thing. Okay, you can just change this limit. Okay, it will be n is equal to b minus a by h. When n tends to infinity, h tends to 0, because h still, if h is 0 only, n will be infinity, right? So h will be 0. So you can just consider limit h tend to 0. Okay, this is also one way. Okay, or okay, simple, or you can just replace h with b minus a divided by n. This is actually very easy to do so. So you can just, final result I'll write here. It will be limit n tends to infinity, b minus a divided by n into f of a plus f of a plus h, so on up to f of a plus n minus 1 into h. This is the formula. Okay, see, I also did not remember the formula, I just derived it, it came, that's all. So I just in the next video, maybe once for 5-6 minutes I'll take and I'll solve one example. Okay, because this is going somewhat lengthy. So many can ask, okay, like this is chemistry channel, why are you posting max videos and all? See, my I like subject chemistry, so I'm doing that. Okay, I'll try to be regular. Okay, because I also have to study. So but what is my aim is not only chemistry. Okay, but whatever I know I'll teach. Okay, there are some audiences who like max, who who want max. Okay, so whatever I know I'll try to teach, and I try to it should reach you. Okay, that is the main aim. Okay, thank you guys, we'll see you in the next video.